Welcome to Engineering Funda family. This video is a part of Microprocessor 8086 video lecture series, and in this video I'll be going to explain you status signals in 8086. My dear students, first of all you should know status signals are available in max mode of 8086. You should know, my dear students, in minimum mode control signals are directly given by 8086, and in maximum mode status signal will be available with 8086, and using status signal we will be giving those status signal to bus controller IC, and bus controller IC will generate control signals. So in minimum mode 8086 will directly generate those control signals, and in maximum mode 8086 will give status signal, and based on status signal 8288 bus controller will generate control signals. Now that is not only the case, which is why we are having status signal. Let me explain you few basic things. It is very essential to know, my dear students. Here in maximum mode 8086 can be interfaced with two coprocessor. So there can be two coprocessor connected with 8086 in maximum mode. Now you should know, my dear students, this main processor 8086 and this two coprocessor are connected with same system bus. Now as these three processors are connected with same system bus, just think about few cases. Like one system is generating control signal, second system is generating control signal, third system is generating control signal. So how many control signals will be there? And all these control signals are connected with same memory, same input output devices. What will happen? It will not provide proper interfacing, and I can guarantee you that it will get collapsed. So here what we do is we generate status signal, and that status signal will be given to bus controller 8288. Now here coprocessor also generates status signal, and that will be given to bus controller 8288. Now whose control signals will get generated? That 8288 don't need to care about. Why? The reason is whomsoever is a bus master will be providing status signal. For example, if 8086 is bus master, then bus master's status will get displayed as a control signal. If coprocessor is a bus master, then coprocessor's status signal will get translated into control signal. That is how case is happening, right? Let me explain you that by graphical understanding, so that will gives you more clear idea. So here, my dear students, you should know status signals are generated in maximum mode only. So here M and MX bar, that will be connected with ground to have maximum mode, and here there are three status signals. Those are S0, S1 and S2 bar, right? And these signals are connected with bus controller IC, right? So here, my dear students, using status signals we generate control signals, and here it is written, you see, bus master is generating control signal. So bus master may be 8086 or it may be coprocessor, right? Here, my dear students, will be connecting 8288 bus controller IC to generate control signal. I'll show you by interfacing also. Here you should know, using 8288 IC we reduce complexity of circuit. I have already told that if coprocessor and main processor generates control signals, in that case system will get collapsed. Why? The reason is there will be many control signals. So here if you have this 8288 IC, and if this IC is only generating control signals, then only those control signals that we need to interface it with memory as well as IO devices, right? So it will be reducing complexity of circuit. And my dear students, 8288, that is not only generating control signal, but it also generates address latch enable, data trans receiving bar as well as data enable signals. I'll show you how it will generate. So my dear students, you see 8288 bus controller IC that is generating address latch enable, data trans receiving bar as well as data enable, right? And here control signals will be there like memory read, memory write, advanced memory read, IO read, IO write, advanced IO write and INTA bar, right? Means interrupt acknowledgement. So my dear students, these are the control signals that is been generated by this bus controller using status, and here you will be observing it is also providing address latch enable, data trans receiving bar and data enable lines, right? Now I have already explained this ALE that we use it to latch address, this DTR bar and data enable that we use it along with trans receiving IC that is to separate data lines, right? So in complete interfacing of minimum mode, I have explained how we can use these terminals even, right? Now my dear students, we are having control signals and this lines ALE, DTR bar and DEN, but how this controller comes to know that ALE, DTR bar and DEN is available? So that is based on clock. So my dear students, with 8086 and this bus controller that will be having common clock, and this status signal that will identify this machine cycles, right? As I have already explained the timing diagram, in that I have told you that in single machine cycle there are total 4 T states. So in first T state there will be address latch enable. So whatever machine cycle that is given over here as a status signal in first T state with respect to clock, 8288 will provide ALE signal over here. After that, you should know that as if it is there with read or write operation, as per this status signal, it will identify whether to transmit data or receive data. And in second T states onward, bus controller will give that data enable signal as per the requirement, right? So that is what happening based on clock synchronization. So common clock that will be given to 8086 and 8288. Now let us try to understand how these control signals are happening as per this status signal. So if it is 000, interrupt acknowledgement will be there. So you see interrupt acknowledgement bar is given. If it is 001, read IO port will be there. So IO read bar will get generated. 010 will give write IO port and 011 will give halt over here. My dear students, here as if 100 is there, then instruction fetch will happen. Instruction fetch means memory read that we are dealing with to do, right, in terms of output control. If it is 101, then memory read that we are dealing with to do, and if it is 110, then memory write will happen. And as if it is 111, then it is inactive, means no control signal will get generated here. So my dear students, based on status signal, it will be generating control signal as well as these 3 essential terminal that will be available, and that is what we can use it for separation of address and data, right? So my dear students, I think now it is clear to you how we will be generating control signals using status signal, right? And in maximum mode, this status will be provided by coprocessor as well. What it means? It means whomsoever is a bus master. Let us say 8086 is bus master, then 8086 will give this status signal and it will execute control system. If coprocessor is bus master, in that case coprocessor will give status and 8288 will provide control. So those control will be there with respect to coprocessor, right? So only status signal, that is what we are giving it to 8288 bus controller IC, and it will be generating control signals. I hope it is clear to you. Still, if any confusion is there, what I want is you just post that in comment box. I'll be happy to help you. Thank you so much for watching this video.